Let's take a little time to talk about SQL transactions. So a transaction, kind of by definition, is a unit of work submitted to the database by a particular user. It could be a particular application. And by unit of work, we're thinking about something larger than individual database SQL statements. So a collection of such statements that we want to be completed as a unit. So it's going to contain, the transaction is going to contain one or many database commands. Could just run a single command. That could be a transaction. Could have multiple commands as a transaction. And the idea here is that we want that group of database operations or database commands to succeed or fail as a whole. So it's kind of an all or nothing proposition. The classic example of this is transferring funds from one account to another in some sort of a banking application. So when you reduce your balance in your savings account by $100 to transfer money into your checking account, you want to make sure that the reduction in the savings account and the increase in the checking account both happen. You don't want to have something go haywire between those two database commands and basically lose money. You want to make sure that either both of those commands succeed or that neither of them do. And even if something goes wrong in the midst of that sequence of database commands, you want to make sure that you roll things back to the point at which the database was in prior to any of those commands being executed. So there's two ways for a transaction to complete. One of them is all of the commands succeeded. At that point, the database is going to ensure that the changes that were made by any of those database commands is made permanent, and we refer to this as the transaction being committed. The other possibility is that something went haywire. Either something happened in the process of doing those commands that was sort of illegal, something that the database itself or perhaps your code itself detected something that it didn't like in a conditional statement, and it caused the transaction to roll back manually. Or maybe the database just crashed. So halfway between that transfer of funds from one account to another, the database itself went down, the server crashed, the power went out, the network connection went away, something like that. In all of those cases, what we want to make sure happens is that the database rolls back to the state it was at the beginning of the transaction. So we're going to undo all of those changes, any changes that may have taken place, even if it's only some of the changes in the transaction. And we refer to this state as a transaction having been rolled back, or sometimes we'll say the transaction's been aborted. The database provides the mechanism for transactions, but it doesn't know when the transactions begin and end in general. So although the database does all of the heavy lifting, it's up to us to make sure that we tell the database, hey, this is the beginning of a logical group of database statements. And we do that with the start transaction or begin statement. In SQL or PostgreSQL, we can use begin, and then this transaction keyword is optional, just makes it a little bit clearer. So that starts a transaction. From that point forward, the database management system is going to be treating all of the database commands that we execute as sort of conditional until we tell the database that the transaction has been completed successfully, which we would do by issuing a commit statement. And we can say commit or commit transaction. On the other hand, if we want to abort the transaction because our code detected that something went wrong, we can also issue a command called rollback, and we can also say rollback transaction. So there's not really a particularly large surface area to this interface. We just tell the database start a transaction, and then when we're done issuing commands to the database, we can tell it to commit that transaction. And if everything proceeds successfully through the transaction to the point where it hits that commit statement, then everything that's changed in the database as a result of those database commands is going to be made persistent in the database. One other kind of nuance here is the notion that's called auto commit. Different databases have different words for this, but it's pretty common to call it auto commit. Basically, the idea here is that the database itself is going to wrap each database statement in its own little miniature transaction if there's no other transaction currently active. So the default, if you don't have a begin statement like we've got up here, and in other words, if you don't explicitly say, hey, I want to start a transaction, the database will effectively act as if there's a transaction that's begun immediately before each individual SQL statement. And then when that statement's completes, if it completes successfully, then the database itself will commit that miniature little transaction with just the one database statement in it. The intention here is to make sure that all of the information about changes that are made to the database are logged into an area of the database that kind of keeps track of the updates that were made to the database that's used as a recovery mechanism. And we're going to talk about that issue more when we discuss database concurrency. On the other hand, if that statement fails, then the database will issue effectively a little rollback that terminates that little miniature transaction that just wraps around the one statement. So you may not have been aware of it, but all along, whenever you've been issuing commands to Postgres, you've been running those commands in little miniature transactions. What we're more interested here is in the larger scope of how do we use transactions to guarantee that multiple of those database operations succeed or fail as a whole. So let me just walk you through an example of using transactions. I've got some simple tables here that represent kind of a account balance model again. Here's a customer table. It's got a customer ID, first name, last name, and email. And I've got some data in there for Fred and Zelda Ziffel. And Fred is customer ID 1, and Zelda is customer ID 2. Here's a checking account table, account number, balance, and customer ID. You can see that the data in there. Here's account numbers. Here's our customer ID, foreign keys to the account table, or the customer table. And we can see that Fred, who's customer ID 1, has $2,000 in his checking, and Zelda, who's customer ID 2, has 5. And then there's a savings account table that's got an account number, balance, customer ID again, and in this case an interest rate as well. And in there we can see that Fred, who's customer 1, has $10,000, and Zelda, who's customer 2, has $20,000. All right. Because we're going to be looking at changes in balances and stuff in this example, I'm going to define a little view here. So create a replace view. I'm going to call it account info, and I basically want to just show information from both the savings accounts and the checking accounts. Let me show you how this what this looks like, and then we'll talk about how it's implemented. So here's what the output looks like. You can see here that instead of just getting savings or checking data, we get both. So here's Fred and Zelda's checking and savings information and the corresponding balances. I'm making use here of the union operator. So I've got a selection here that's coming from the savings table, and I'm joining in the customer information and printing out the account number, the account type, the customer ID, first name and last name, and balance, as you can see here in the output. And then I'm unioning that together with essentially the same select statement, but now getting information from the checking table. And I'm arranging for these two interior select statements to give back the same shape of information. So the table has the same columns in the same order with compatible types. The only thing that's a little weird here is that I'm explicitly calling out the type of the account. So here I'm saying return as part of the select the expression saving, just a literal string here. That's a perfectly legitimate SQL expression and shows up in the output as either saving or, in this case, the second one, as checking. In order to make those things easier to manipulate here, and you can see here I'm actually ordering by account type here within the customer first and last name, I'm giving that column that just has that literal saving or checking an alias of account type so that I can sort against it. Okay, so that's just a convenient view that we can use to transfer funds. So what I'm going to do here first is just illustrate the transaction behavior, and I'm going to be using account number 2, which is Zelda's account here. So that's the one we want to keep our eye on. So first of all, I'm going to start a transaction. So execute the begin transaction. Now there's an active transaction within which the next series of database commands are going to execute. And what I'm going to do is transfer $100 from Zelda's savings account to her checking account. So update saving, remove $100 from the account where the account number is 2. Notice that because I defined these tables up here as having a balance of type money, which is a specific data type that's tailored to dealing with currency, I have to cast the value that I'm using here in my SQL statement to be of type money. Otherwise, this would just be a numeric type, and I'd get some complaints from Postgres. So this is how you can do it's a kind of a Postgres specific syntax for casting a constant, in this case, to a particular type of money. So I'm going to execute that and remove $100 from Zelda's savings account. Now, if I went and refresh my account info down here at the bottom, we can see that now Zelda's got $19,900, so it's $100 less here in her savings account. And I want to but I haven't yet updated her checking account, so it still shows $5,000. So I execute this second update statement and then go and check on the results. You can see that now we've successfully transferred $100 from Zelda's savings to her checking account. Now, if at any point during this set of commands inside the transaction something had gone wrong, we would have removed those changes that were made all the way up to the point where the transaction began. Because it's a little hard to coerce something to break intentionally, I'm just going to manually roll back that transaction. And now if we go back and requery the database for that account info, you'll notice that that restores the checking and savings account that Zelda has back to their original values at the time that the transaction was started. Now instead, if we want to demonstrate the ability to commit the transaction successfully, let's go back and start a transaction all over again. And then we're going to execute these two statements to transfer the funds again, just like before. And then I'm going to select the data from the account tables in the database. And we can see that the transfer has taken place from Zelda's saving to Zelda's checking account. Now, instead of doing a rollback, which would remove those changes, instead I'm going to do a commit transaction. And when I execute that, the transaction is now complete, and there's nothing else I can do to make any changes. I've persistently forced those changes out into the database itself, and no rollback is gonna do anything. Next, I want to just illustrate doing these kinds of operations inside of a procedure. So I'm going to define a new procedure called saving to checking, and it's going to take two parameters: the customer ID as an integer, and then the amount of the transfer as of type money. And this is just a SQL procedure, right? It's not PG, PL SQL, it's just ordinary SQL. And those kinds of procedures or functions are quite a lot simpler. In particular, these procedures don't return any values, so there's no return statement here. And all I've done here basically is just wrapped up the same update statements that I've executed just above, except I've put them inside this procedure, and I've used the parameters that I'm passing into the procedure, the amount and the customer ID, to accomplish the specific transfer from savings to checking. So we're still in the same condition we were in after the transaction was committed. So Zelda has $19,900 in savings and $5,100 in checking. And now I'm going to transfer, I'm going to call that saving to checking procedure for customer ID 2, which is Zelda, in the amount of $150. So execute that. And if we go back and rerun our select from account info view, we can see now that there's been more information, more money transferred from Zelda's savings to checking. Now, when we do this in the context of a transaction, we have now control over whether or not the results of calling that procedure are persistent or not. So I'm going to just execute these things one at a time. So start the transaction, then I'm going to call the transfer. And then this is just the, so I should have transferred $150 again from Zelda's savings to checking, and then this will allow us to verify that by looking at the database, and you can see that the balances have changed by that amount of $150. And then if I do a rollback here, I could do a commit as I did before, but I'm going to do a rollback here to illustrate the notion that we're undoing the actions that took place inside that procedure. So do the rollback and then come back here and select from account info, and we can see that the balances will go back to what they were as of the completion, the commit of the most recent transaction. So we've rolled back to the state that the database was in prior to this begin transaction. Notice that, and I'll post this source code, but notice that I'm just kind of using this as a convenient sort of scratch pad to do these operations. So, I've got a commit transaction immediately followed by a rollback transaction. This whole file is not intended to be executed in series. It will do weird things. It's just here so that it's easy for me to demonstrate this behavior for you, as opposed to an example of standalone source file for use in your database unchanged. Here's some information about transaction availability in functions and procedures in PostgreSQL. So I've got a little table here that shows when you are allowed to use transactions, and it turns out it's fairly limited in the sense of using them inside of these functions. So I've tried to call out two particular types of functions and procedures that we can write. So if we're writing just in regular SQL functions, which is just a sequence of SQL operations without any sort of control flow or whatever, we pretty much can't use transactions in any of those cases. It's just not supported by the database. On the other hand, if we're writing in a procedural language like PLPG-SQL, we can use transactions explicitly in procedures. We can't do them in functions or trigger functions, but we can use them in procedures. So here's just some kind of notes about that. So function and trigger function can't start or commit a transaction. Basically what a function is doing, or a trigger function is doing, is assuming that any kind of transaction boundaries that it's operating within have been established from outside of the function, which kind of makes sense in that the function, if you think about just an ordinary function, you're invoking that inside the context of another statement, like inside of a select statement, for example. So starting a transaction sort of in the middle of a select statement is really kind of too fine-grained, too low level. So although the function itself can't start or commit a transaction, the larger context in which, say, the select statement in which that function was embedded could in fact start a transaction. In terms of a procedure, you can't actually start a transaction in a procedure, but you can either commit or roll back a transaction in the procedure. And when that happens, obviously the commit or the rollback takes its effect, and then the procedure will automatically start a new transaction from that point going forward. Note one of the things that might be confusing, since we talked about PLPG-SQL, that it has a begin and end statement, and that seems to conflict with the begin transaction. But in PLPG-SQL, the begin is always just used as a mechanism for grouping, right? It creates a block in that block structured language. It never actually is something that starts a transaction.